Today we're going to look at compositions of functions using graphs. We're going to use these two graphs to find the indicated quantities and explore this topic. You'll see that the left graph is named f of x and the right graph is named g of x. We're going to start with something that you already know. We talked about this in interpreting graphs. So if we want to solve this expression, negative 3 times f of 2 plus g of negative 3, we simply use 2 as our x value for the f function and locate the point on the graph that has an x value of 2. And I've highlighted that point. Notice that the corresponding y value is 2. So f of 2 refers to the y value when x is 2. In this case, it's also 2 coincidentally. For g of negative 3, I will of course refer to the g function. G of negative 3 means I'm looking for the y value when x is negative 3. So I find my x value of negative 3, and on the graph I note that when x is negative 3, the y value is negative 2. So I simply substitute those y values into my expression and use order of operations to simplify. And so this quantity is negative 8. Let's practice another. G of 3 means I'm looking at the g function, the one on the right. When the x value is 3, the y value is 1. And then for f of negative 1, I'm looking for the y value when x is negative 1, and that is, of course, negative 3. Just be careful for signs because that would be a real easy place to make a mistake. 1 minus negative 3 is 4. All right, let's try another one of these. So negative 2. So we are looking at the g function. I almost looked at the wrong graph. Notice that when x is negative 2, the y value is 0 because that particular point lies on the x-axis. And for the f function, when x is 3, the y value is coincidentally also 3. But 0 times anything is just a 0. Now this example is getting into actual compositions of functions. Notice that I have a function within another function. Whenever you're solving compositions of functions, you always start with the inside function first. So the first thing I'm going to find is f of negative 1. Remember, that means I'm looking for the y value when x is negative 1. I've highlighted that point on the graph. When x is negative 1, the y value is negative 3. So f of negative 1 is negative 3. And I substitute that newly found value into the g function. It's interesting to note that negative 3 was a y value. But now that I'm finding g of negative 3, it is an x value. So I want to know the y value when x is negative 3 for the g function. And that y value is negative 2. So I use an x value to find a y value. That y value then becomes the x value for the other function, and we find the y value that goes with it. So input, output, we use the output as input in the other function to get our final answer. If that's clear as mud, let's try another example. So we're finding f of g of 0. Again, we always start in the middle. G of 0 means we're going to find the y value when x is 0 on the g function. I've highlighted that point. When x is 0, the y value is 2. Now we're going to use 2 as the x value for the f function. F of 2 is coincidentally also 2 because this point has the coordinates 2, 2. Let's do another one together. Again, the way you read this is g of f of negative 2. And you always start in the middle and find f of negative 2 first. So be careful to use the function graphed on the left. When x is negative 2, the y value is negative 1. So f of negative 2 is negative 1. Now, negative 1 becomes the x value in the g function. And in the g function, when x is negative 1, the y value is 3. Pause this video and see if you can find g of f of 0. Did you find that f of 0 is negative 2 and g of negative 2 is 0? I sure hope so. But if not, I have a few more for you to try. What about f of g of negative 3? Again, you could pause the video for just a moment and then resume when you have the answer. So we find g of negative 3. When x is negative 3 in the g function, the y value is negative 2. So g of negative 3 is negative 2. And f of negative 2 is negative 1. Again, you can see the highlighted point indicating that. How about f of g of negative 1? Did you get that g of negative 1 is 3? And that f of 3 is 3? Let's try a few more. How about g of f of 3? Again, always remember to start in the middle. F of 3 means find the y value when x is 3. And in the f of x function, we know that when x is 3, the y value is also 3. So f of 3 is 3. We make that substitution. And g of 3 is, of course, 1. Now it's getting interesting. We're going to find f of g of f of 1. It looks very complicated, but let's just take it one step at a time. Start in the middle and work your way out. So start by finding f of 1. F of 1 is 0. So substitute 0 in place of f of 1. It's looking a little bit better now. We're now to find f of g of 0. Again, the middle part is g of 0. On the g function, when x is 0, the y value is 2. So now I have it simplified to f of 2. So we're going to go back to the f function and find f of 2, which is, of course, 2. Let's try another example where we have several embedded compositions. The way we would say this is g of f of negative 3. But we start in the middle with f of negative 3. F of negative 3 is 1. So we take f of negative 3 and replace it with the number 1. Now I'm finding g of 1. Begin with g of 1, and I see that g of 1 is negative 1. We're going to reuse the g function, but the negative 1, which we found, the y value that corresponds to 1, is now an x value. So we find that when the x value is negative 1, the y value is 3. In this example, we're taking it up a notch. So we're getting close to the end here. All right, so this is a little challenge for you. It says if h of x is equal to x squared minus x, then for what values of x is h of x equal to g of f of 1? Please notice that h of x is not graphed here. So h of x is not represented at all by these graphs. The only thing these graphs are going to be useful for is finding the right side of this equation, g of f of 1. So let's work on that first. Let's find g of f of 1. Well, let's find f of 1 first. When x is 1, we see that the y value is 0 for the f function. So now I substitute that 0 back into this expression, and I find g of 0. G of 0, according to the graph, is 2. So what I've found is that G of f of 1 is 2. Now what we want to know is where h of x is equal to 2. So I don't need these graphs anymore. I needed them to help me find the value of G of f of 1, and I've found that it's 2. So now I simply set x squared minus x, which is h of x, equal to 2 and solve. This is a quadratic equation. When you're solving a quadratic equation, it is often helpful to get all your terms on the same side. So I subtracted 2 from each side. This was a nice and easy factorable trinomial. It factors into x minus 2 times x plus 1. If you were to perform the FOIL, first times first, outside times outside, inside times inside, and last times last, it would simplify to this trinomial. So factoring is just the FOIL method backwards. Once you have the two factors, you can use the zero product principle. This set of parentheses times this set of parentheses equals 0. That means one of those sets of parentheses must equal 0, because that's the only way you can multiply two quantities and get an answer of 0. So now I just have these tiny little equations to solve, and I find that x is equal to 2 or x is equal to negative 1. And those are the values where h of x is equal to 2, which is g of f of 1. And I'm finished with this problem. I have another problem here that is similar, and this will be our final problem. If p of x is equal to 3 times the absolute value of x minus 2, then for what values of x is p of x equal to f of g of negative 2? Again, notice that we don't have p of x graphed here at all. We're only going to use f of x and g of x graphs to find this number, f of g of negative 2. So let's do that first. So let's find f of g of negative 2. Always beginning with the inside, first find g of negative 2. And I notice that g of negative 2 is equal to 0. And now I make that substitution. G of negative 2 is 0, so now I'm finding f of 0. And f of 0 is negative 2. So step 1 is complete. I have found f of g of negative 2. That's the only thing I needed these graphs for. Since f of g of negative 2 equals 2, I'm going to set p of x, which is 3 times the absolute value of x minus 2, equal to 2 and solve. For an absolute value equation, when you solve it, your first order of business is to isolate your absolute value bars. So I do that by dividing both sides by 3. Now the left side of my equation has only the absolute value expression. Remember, this means that x minus 2 is 2/3 units from 0 on the number line. There are two numbers that are 2/3 unit from 0 on the number line, negative 2/3 and positive 2/3. So I set x minus 2 equal to both numbers and solve. And in absolute value equations, you will often get two answers, as I have done here. And that's it. Good luck, guys.